Okay, number 5. It says 2 forces of 70 and 100 pounds are acting on an object. The object is standing in a vertical position and the forces are acting at a 40-degree angle to each side. So that would mean 40 degrees, right? And another 40 degrees on this side. Okay? And so this one, let's make this one 70 and this one 110. And says find the magnitude and direction with respect to the horizontal axis. So we just need theta as our normal trig. So here we go. First, we need the angle. So this first angle of the first vector would be 50 degrees, right? If it's going to be 90. So that would be 70 cosine of 50 degrees and then 70 sine 50 degrees. The next one would be all the way 90 plus 40, which is 130. So it would be 110 cosine, 130 degrees, 110 sine 130 degrees. Okay, so let's add those together. V1, V2, V1 plus V2 is equal to, you should get 25.71 and 137.89, and then the magnitude of that would be 25.71 negative squared plus 137.89 squared, which you should get 140.27 pounds. Okay, tan theta, or theta, is equal to inverse tan of 137.89 over negative 25.71. Is it supposed to be negative? Let me see. I got, it's okay. I got negative 79.43, but this is in quadrant 2, so add 180, and you get, see, I got 79.44, and then we need it to be in quadrant 2, so we are going to add 180, and you get 100.56 degrees. I think on the homework, on the handout, I had switched which, it doesn't say which one is 70 and which one is 110. So if you did it that way, you would have 110 and 70, and it would be in quadrant 1. It would come out positive. So it's because I made the weight of the pull more greater in quadrant 2 than quadrant 1 in this case, and not on the homework. So both are correct. It's the way I set it up, the two ways. So if you set it up the other way, then you would get the same because this is going to be the same either way, but the angle theta would be 79.44. Okay, so that was number 5.